Science is built on curiosity, but what happens? It becomes trapped in dogma. Sabin Hossenfelder, a theoretical physicist and author, has made her mission to challenge the status quo. From quantum gravity controversies to the overhyped promises of AI, from the flaws in string theory to the corruption of scientific funding, she has fearlessly exposed the cracks in modern physics and academia. In this deep dive, we'll explore her most thought-provoking critique and why they matter. So first of all, we should have to understand about the quantum gravity controversy. Quantum gravity is one of the biggest unsolved puzzles in physics. We need a theory that unites quantum mechanics and general relativity. Yet the scientific community is deeply divided. Hossenfelder has been a vocal critic of certain approaches, particularly those rooted in a mathematical beauty rather than empirical evidence. She argues that theories like string theory and loop quantum gravity have dominated the field of decades without producing testable prediction. In a debate with Brian Cheating, a cosmologist of San Diego, she pointed out that physicists often mistake mathematical elegance for scientific progress. Cheating, while agreeing with some of her criticism, defended the role of theoretical models in guiding future experiments. So are we chasing equations that look nice on paper rather than seeking truth? Hossenfelder warns that quantum gravity research is stagnating because scientists are prioritizing aesthetic over reality. Second section, the AI hype. Artificial intelligence is another hot topic, but is it as powerful as tech companies claims? Hossenfelder doesn't think so. In one of her videos, she debunks the exaggerated promises of AI, replacing scientists and achieving human-like consciousness. She explains that current AI, including large language models like GPT, are incredibly sophisticated pattern recognition systems, but they don't understand the world like humans do. The hype around AI is largely fueled by marketing, not scientific breakthroughs. She warns against investing too much faith in machine learning to solve fundamental physics questions, as it lacks true reasoning capabilities. Another controversy, string theory and theory of everything. For decades, string theory has been hailed as a theory of everything. But does it really hold up? Hossenfelder has been fierce critique, arguing that the string theory is more of the mathematical playground than a scientific theory. One of the biggest issues he highlights is that string theory hasn't made a single testable prediction. It requires extra dimensions, supersymmetry, and enormous landscape of possible solutions, all of which have failed to appear in experiments. Yet despite these shortcomings, continues to dominate funding and research opportunities. Instead of chasing an elusive theory of everything, she believes physicists should focus on solving real-world problems like improving quantum gravity models and improving theory of dark matter and dark energy. And number 4, drives in science. What if science isn't as pure as we think? Hossenfelder reveals the hidden corruption in research funding. Many grants, awards, and promotions are tied to politics, reputations, and institutional biases rather than genuine scientific merit. She exposes how prestigious journals favor flashy, groundbreaking claims over careful, incremental research. This pressure leads to exaggerated findings, manipulated data, and sometimes outright fraud. In a famous case of superconductivity research scandal is just one example how money and prestige can distort the scientific process. Her solution, reforming the peer review process, increasing transparency in funding decisions, and encouraging independent replication studies. Without these changes, she warns science risks to becoming a self-serving enterprise rather than a pursuit of truth. And section 5, I fail, why academia fails. In it, she opens up about her struggles in academia and why the system is fundamentally broken. Despite being a highly accomplished physicist, she found herself disillusioned by the public or Paris culture. The lack of creative freedom and the pressure to conform to mainstream ideas, she described how the system discouraged unconventional thinking and penalized those who challenge established norms. Her critique resonated with many young scientists who feel trapped in a cycle of chasing citation rather than exploring meaningful questions. If we want science to progress, we need reward intellectual diversity, not just conformity. So what's the takeaway from all of this? Sabin Hossenfelder isn't just criticizing science for sake of it. She's calling for better, more honest scientific culture. Whether it's quantum gravity, AI, string theory, or the flaws in academia, her message is clear. Science should be about the seeking truth, not following trends. What do you think about her ideas? Are we too focused on mathematical beauty or empirical reality? Is AI truly revolution it claims to be? And how can we fix the flaws in modern academia? Let us know in the comment below.